glycogen, which is complex fibers of sugar. So we take that glycogen out of the liver, break it apart into glucose, and put it back into the bloodstream to raise our blood glucose level. That's part of what growth hormone does. That's a huge part of it. In addition to that, it also helps stimulate muscle growth and bone growth through protein stimulation and osteoblastic activity. Or is it osteoclastic? It's building bones.
I think osteoblasts build on an osteoclast. Tear them apart.
And you're right.
So.
Yeah.
I think so, yeah. So it's osteoblastic activity. So that's growth hormone. Adrenocorticotropic hormone. Break it apart. Corticotropic. Tropic means it affects an endocrine organ. Adrenocortico, it's referring to the cortex of the adrenal gland.
Okay.
So this is going to the cortex of the adrenal gland.
Okay.
Now, the cortex of the adrenal gland produces 3 different types of hormones. It produces glucocorticoids. It produces mineral corticoids. And it produces androgens. Androgens were first heavily studied in men, understood in men, so it's named after men, androgen. However, there's sex characteristics for both genders. It's not specifically for men. There's higher levels of it in men, though. Androgens have to do with sexual maturation, things like pubic hair, voice dropping, things like that. Those come out of androgens, so it handles what is known as secondary sex characteristics.
And in this slideshow, he calls it sex hormones. People call it androgens.
He called it sex hormones?
Yes.
Well, that's more
Estrogen,
politically
progesterone,
correct,
testosterone.
but your book calls it androgens.
Okay.
Wait, no, estrogen is not an androgen. Estrogen and testosterone are coming from your gonads, not from your adrenal gland.
That's the
So your adrenal gland is going to be androgens, but you will have estrogen and testosterone from your gonads.
Okay, because adrenal cortex, mineral corticoids, glucocorticoids, sex hormones.
Interestingly enough, testosterone is an androgen, but estrogen is not. So that's why he's calling them sex hormones, because he's including those 2 in the list. But if you're just talking about the cortex of the adrenal gland, it's just androgens.
Okay. So he just simplified things, I guess?
Yeah, he simplified and grouped them together. They come from different places, though. Alright, so glucocorticoids. There is one glucocorticoid that you should know, and that's cortisol. And there is one mineral corticoid that you should know, and that's aldosterone. And I've already mentioned aldosterone. Aldosterone has to do with being contrary to antidiuretic hormone. So aldosterone and vasopressin work together to maintain our blood pressure.
Using sodium.
Exactly. And other minerals as well. Primarily sodium, but other minerals too. That's why they're called mineral corticoids. They have to do with the electrolyte composition in the kidneys.
So are they using osmosis here to keep things balanced by using salt?
They are. They're using an osmosis pump in the kidneys. We'll go over more of that when you get to renal and we start studying the function of nephrons. And you won't really understand all that until you study it again in physiology. And then you actually talk about the different solute levels at the different points of the nephrons. But yes, it does manage the solute levels, and it does manage it through an osmosis pump in the simplest terms. Cortisol, however, cortisol has to do with our stress management. Now, when we studied nervous system, I told you about how you get a neurological stimulus for sympathetic first. Seconds later, you get the hormonal stimulation. So epinephrine from neurons and then epinephrine from the medulla of the adrenal gland. When that goes on for too long, you switch to cortisol. Cortisol is great for handling stress and allowing us to go back into parasympathetic mode.
That's why it's used in diet pills.
Yes. So it really helps with that. Now, in order to handle stress, we need a little more glucose going on, so it's again going to go to the liver, and break down glycogen stores and increase our blood supply. And that's primarily how it helps us with stress. There's other things that it does too. But a key important thing that it also does is it is an immune system suppressant. That's why it's not healthy to be stressed out too long, because you break down your immune system and you're using up your glycogen stores, so you will eventually, under enough stress, you'll eventually run out of glycogen stores and you'll run out of your sugar, and your blood levels will not be able to maintain themselves. You'll get irritable, you'll get tired, you'll get sick more often, you'll get all sorts of health drawbacks. So when you look at your neural stimulation of epinephrine, you're looking at the first few seconds of stress. When you look at your hormonal stimulation of epinephrine, you're looking at a follow-up. So you're lasting from those seconds into minutes, sometimes into hours, sometimes into days. After you've had enough, our body needs to go back to parasympathetic. That's how we grow, that's how we develop energy. We have to get back to it. So we're going to switch to cortisol in order to accomplish that. It helps us manage the stress and allow parasympathetic stimulation to encourage our digestion and growth and sleeping and all that. The downside is, again, immune suppression and the drain on the body, which is why it's not preferred. Epinephrine is preferred, but we can't stay in it. So we have to switch to cortisol. This can go on for days, weeks, months, potentially years. You will continue producing cortisol as long as you're stressed out. Right now, your body's running on cortisol from your class. That is a reality. And a little bit of cortisol and stress is good for you. It's healthy for you.
That's why it comes from nuts.
Yes. A little bit is good for you. A lot of it is detrimental. It's like alcohol. You have a glass of red wine with every dinner. It's very good for you. It's got wonderful heart health benefits, and the damage it does to the liver is so minor at that level that our liver can completely repair it every day. No problem. It's when you have more than that when you start having serious health drawbacks. Same thing with cortisol. Okay. All right. So that covers your adrenal cortex, pretty much in a nutshell. Now let's go ahead and look at our, actually I'm going to jump to thyroid-stimulating hormone. Thyroid-stimulating hormone, guess where it goes?
To your thyroid.
To the thyroid.
Where it competes with calcitonin, right?
I am losing my to the thyroid. It doesn't compete with calcitonin. Thyroid-stimulating hormone encourages the thyroid to release thyroxine, which is your T3 and T4.
I thought T3 was tridothyroid.
And T4 is the thyroxine.
Okay.
Yeah. It produces both of them at the same time. T3 is what actually enters your cells and increases metabolism. T4 goes to the cells and through a carrier protein is converted into T3. Then it goes into the cells. So ultimately the end result is T3 inside your cells increasing metabolism. T4 is kind of a byproduct or an accidental product, however you want to think about it. Curiously enough, we make more T4 than we make T3. Interesting, huh? I think that's proof against intelligent design. Now, T3 and T4 are going to go to your cells and they're going to increase metabolism, which also has the direct effect of increasing body temperature. So T3 and T4 maintenance is important in maintaining your body temperature. Okay, now we've covered that guy. Your thyroid, separate from this, will also produce calcitonin. Calcitonin is going to be opposed to parathyroid hormone. And that has to do with your blood calcium levels. Calcitonin takes the calcium out of your blood and puts it into your bones for storage. And parathyroid hormone, if your blood glucose level is too low, it'll take the calcium out of your bones and put it into your bloodstream. So always get your calcium intake.